Hello, everybody. It's Mrs. Pound, and I'm back with more about work and energy from chapter 4.2. So, our topic today is going to be power, machines, and force from section 424. Our objectives are going to be to define power in terms of work and time, describe the benefits of machines, and calculate mechanical advantage. So, when I talk about power in science class, it's different than the way we use the term power in, say, English class or elsewhere in just normal language. When I talk about power, I'm talking about the amount of work done or energy provided in a period of time. So I'm timing how long it takes me to do work. And actually, we're going to apply this in class. We are going to do a lab where we figure out how much time it takes you to do the work of going up a flight of stairs. So we will apply that. Now, also, work is applied to our energy consumption, or excuse me, power is applied to our energy consumption. For example, LED bulbs produce more light with less power than incandescent bulbs, so they conserve energy. Because they use less energy in the same amount of time, they are more powerful and it costs us less money, so we like that. So that's why a lot of people at home are changing their incandescent light bulbs out for LED bulbs. And in the background, that's actually an incandescent. So we have a formula for this. It's power equals work over time. P equals W divided by T. And the unit is a joule per second or a watt, which should sound familiar because that's used for light bulbs, right? Now, how much energy is needed to lift a 10-kilogram crate 10 meters in 10 seconds? This is the kind of question you might see for power. And in this problem, we're going to need to use three different equations because we have our power equals work over time, but we don't know the amount of work. So we have to find the work and we have to use the formula force times distance. But we don't know the force yet. So we have to use the equation force equals mass times acceleration. And we can use the mass right here to figure that out. So our first equation is that F equals m times A. We plug in our numbers, 10 kilograms times 9.8 meters per second squared equals 98 newtons. We then use that force and plug it into our work equation. Work equals force times distance. So our force is 98 newtons from the previous problem, 10 meters from right here. Multiply those together, we get 980 joules. Remember, the unit for work is joules. We then can plug that into our power equation. So P equals work over time. So the amount of work we did was 980 joules. We did it in 10 seconds. So 980 divided by 10 is 98 watts. That is how much work was done. Now, a lot of times we like to make our work easier. Who doesn't like their work to be easier? And so in science class, to make work easier, we use machines. This is a device that makes work easier by changing the size or direction or both of a force. And some examples are pulleys, gears, and levers. When we use a machine, we talk about the resistance force. This is the force needed to do work without a machine. So here you have a mother carrying a baby on her back. She has no machine, she's just carrying the baby herself. We also talk about the effort force, the force needed to do the same work with a machine. This mother in this picture has chosen to use a machine to help her with that work of carrying that baby from point A to point B by putting the baby in a stroller, which is a machine. Now, this provides that second mother with some mechanical advantage, and this is a measure of how much a machine increases a force applied to it. And there's a formula for that. The formula is mechanical advantage equals resistance force divided by effort force. So to write that using symbols, MA equals FR divided by FE. So an example of a problem might be calculate the mechanical advantage when the effort force is 50 newtons and the resistance force is 100 newtons. So here I have plug them in. My resistance force, which goes on top, is 100 newtons. My effort force is 50 newtons. And when I divide those numbers, I get a mechanical advantage of 2. So what that means is it multiplied my effort force by 2 to match the resistance force, is what the machine did. This calculated mechanical advantage is ideal mechanical advantage. It does not take friction into account. So in the real world, my mechanical advantage will not be that much. This is just calculated due to no friction. Now, a pulley has mechanical advantage, but a single pulley like the one shown in the picture has a mechanical advantage of 1. So why in the world would we want to just have a mechanical advantage of 1? We want to do less work. Well, sometimes we just want to do the work in another way. That actually makes it easier. So the mechanical advantage of a single pulley is to change the direction of the force. It is actually easier to pull down and use a little bit of gravity than to pull up on a box. So if you're trying to really lift something heavy, it's easier to pull down and change that direction than it is to just lift it up yourself. That's the mechanical advantage of a single pulley. If you add pulleys to the system, you do in fact multiply the mechanical advantage in your force. And we'll talk about that in the next chapter about simple machines. So, our objectives today were to identify forms of energy in a given system, compare renewable and non renewable resources, and determine methods for conserving energy. Now, if you have been listening to this video the whole time, I would like you to put a smiley face by your name because I think a lot of people have not been listening to the videos through the whole way. And so this will tell me that you actually have listened, and those who don't have a smiley face will have points taken off of their packets. So don't forget your 5 questions, and I will be back with, I believe, one last section about um, work and energy.